Okay, this is the answer key for the 6.5 Part 2 homework. Now, I'm not going to go over questions 9 through 14. Those are based on the nature of the graphs, and I really believe that if you think hard about all of them, you'll be able to answer them. They might be worded a little bit funny, but I know that if you stop and you think, you'll be able to figure them out. If you're spending 2 or 3 minutes and you can't get there, stop and look at the answer key. The answer key written should explain everything you need there. Now, every other question is just graphing. So for all of the functions, you're expected to graph the function for at least 2 cycles, and that's all it's asking you to do. So I'm going to go ahead, I'm going to do number 27, 29, and number 40. Those should be emblematic enough of what you're doing in the homework to get you through. So I'm going to make sure that I do a kind of easy one, a little bit of a medium one, and then obviously the hardest ones I'm expecting of you. So for number 27, I'm looking at y is equal to -3 times the cosecant of x. That's the graph that I'm aiming to do here. So I'm going to actually graph y is equal to -3 times the sine of x. I've got an amplitude of 3, a period of 2 pi. I have not shifted that. And I also have a reflection about the x-axis. So I'm going to go ahead and graph this function of sine. Let's scale my x-axis by pi over 4s. And let's scale my y-axis by 1s. Sine still has that 0.00. I'm scaling this by pi over 4, so at pi over 2 it would be -3, pi at 0, 3 pi over 2 +3, 2 pi 0, 5 pi over 2 -1, since I'm reflecting this about the x-axis. And then I can work backwards as well to get a couple cycles of the sinusoidal wave. I can go through and draw my sinusoidal wave through it. Now, I'm not going to go into the theory of this, all the theories in the notes. I'm going through how you get the answers for the homework. I know that I need a vertical asymptote wherever this graph of -3 times the sine of x intercepts the x-axis. And then I know what I'm mostly concerned with is you knowing that these graphs are going to overlap with a minimum or maximum of the parabola at a peak or valley of the sinusoidal wave, depending on the situation. And then it's just going to approach those vertical asymptotes and adhere to asymptotic behavior. This is what it looks like on the answer key. Again, I believe on the answer key, you're looking at black and blue for the sine and cosecant graph. I apologize for that, but that's just what it has to be. In order for it to work on the scanner, I need it to have those ink colors. Now, technically, your correct answer, I am going to go through. I'm going to erase the sine section of this graph because I'm really only concerned with the points of where my minimums or maximums of these parabolas are. And there you have it. That is -3 times the cosecant of x. Much easier to think about that as -3 times the sine of x, and then to just do some quick adjustments based on that. Again, we're going to keep adhering to the same principle. When I'm looking at y is equal to 4 times the secant of 1/2 x, I've got an amplitude here of 4. I do have a period shift in this case. So my period is now 2 pi divided by 1/2, which is going to be equal to a period of 4 pi. Let's go ahead. I'm going to scale this x-axis by 2 pi. to make my life a little bit easier. And we're going to keep scaling this y-axis by 1. So here, I'm looking at y is equal to the cosine, 4 times the cosine of 1/2 x for my base function. So that cosine is going to start, in this case, at 4. And then it's got to get back to 4 by the time I'm at 4 pi. Since I'm scaling this by 2 pi, that's where that point would occur. From here, I can think about all the parts of the quarters of my graph just like I did on that cosine sine graphing homework. So I'm going to go through, I'm going to break down this graph into the quarter values that exist of it. And then I'm going to draw my cosinusoidal wave. Now this is the hard part. Graphing that cosinusoidal wave based on the amplitude of 4 and that period of 4 pi is the hardest part, because now all I have to do is yet again go through and draw my vertical asymptotes wherever this is 0. Then I go ahead, I put my minimums or my maximums of my parabolas at my peaks or my valleys as necessary. I draw them in the correct direction. I follow the asymptotic behavior. And there you have it. Again, the hardest part about this is actually graphing that 4 times the cosine of 1/2 x. And you can see why it's so essential that you understand how to do that, and why I reviewed that in class on Monday or Tuesday. I wanted to make sure that we knew what we were doing there before we did this. Now finally, question 40, y is equal to 3 times the secant of 1/4 x plus 1. So this one actually is going to be a pretty good sample of the hardest ones you have. And this is pretty much the hardest that we've done yet. You're looking at a graph with a period shift, an amplitude shift, and a vertical shift all at once. And then on top of that, we have asymptotes, and we have to graph another function first. Now this is the secant, so that means we are looking at y is equal to 3 times the cosine of 1/4 x plus 1. Amplitude is 3. Your period is 2 pi divided by 1/4, which means you're actually looking at 8 pi. And then you have this vertical shift up 1. So we're going to make a fake x-axis at y is equal to 1. Again, let's go ahead. We'll continue scaling these y-axes by 1. So that means I'm going to have this fake y-axis at positive 1 here. I've got a period of 8 pi. We're going to go ahead and scale this x-axis by pi. And one thing I actually just realized, I was scaling this previous example by pi over 2. Amazing what happens when you stop and think. So if you were looking at that example and wondering how in the world my scaling by 2 pi looked at that, that's because I wasn't scaling by 2 pi. I was scaling by pi over 2. I greatly apologize for that. Hopefully you haven't gotten caught on that confusion. I will try to go back through the video and make sure you understand that. I'm also going to make a note of that on the Google Classroom instructions. Now that I realize that, scaling this one by pi, I am talking about cosine. It has that amplitude of 3. I have this fake y-axis. So there we have it, 3 above that fake x-axis. and then it's going to have to return to that point by 8 pi. And again, I can break this down into my quarters and what happens in my quarters and just follow that amplitude. And then I can draw that cosinusoidal wave. And then I'll draw my vertical asymptotes. Again, just like I pointed out in the notes, you have to draw your vertical asymptotes through this new fake x-axis. It's not where it crosses the x-axis. If you do it where it crosses the x-axis, you're going to end up with some just radically incorrect vertical asymptotes. Again, we take the secant of the function before we add 1 to it. So wherever that secant is undefined is going to stay undefined at those regular values. We're not doing anything with that vertical shift to then change our vertical asymptotes to where it intercepts at the x-axis. We're doing it at this fake x-axis. I'll go through peak valley, max min, draw my parabolas approaching those vertical asymptotes. This is not perfect. This is not the prettiest thing in the world. I'm hand drawing these graphs. I don't expect these graphs to look absolutely perfect on your tests and quizzes. I'm much more concerned about the general theory of them. Then I'm going to go through. I will actually erase this. That's not what it looks like on your answer key. Again, I needed it to scan properly, and there you have it. Now you have that graph. Looks kind of ugly from the beginning, but again, since I know my cosine graph so well, I'm able to go through and do that. This is the homework for the night. If you have any questions, again, please do not hesitate to email me. Email me sooner rather than later. Have a great night and have a great weekend.